So I'm gonna record a video, a test review video for module 5. It's only gonna be going over 5.3 and 5.4, so linear programming stuff. All right, let's get started. So I'm starting with number 39 on the homework. So for this one, it's a system of 3 equations. I want to solve this out. So when you solve a system of 3 equations, what you want to do is you want to figure out, well, first you want to see, do you have a coefficient of 1? If you have a coefficient of 1, it makes your life a lot easier. But in this case, we don't. So if you don't have a coefficient of 1, you want to look at your variables and see, well, which one is very easy to cancel out. So in this case, if I look at my x's, y's, and z's, my z's are going to be pretty easy to cancel out. And that's because the 6 and the -4 are multiples of 2. So they're very easy to deal with, very easy to cancel out. So that's what I'm going to do. I'm going to cancel out the z's. And that's kind of how you want to start all these systems of 3 equation problems. You want to start them out by seeing which variable do I want to get rid of. In this case, I chose the z's because of what I said. 2, 4, and 6, they're all multiples of 2. So I can use that third equation to get rid of the z's in the previous 2. So I can multiply equation 3 by 2 and add it to equation 2 to get 4x plus 6y plus 4z is 8. Equation 2 is 5x minus 2y minus 4z is -1. If you add these, you get 9x plus 4y equals 7. Right? Yeah. That's 7, and I can call this equation 4. And then I can use equation 3 again, because 2 is very easy to turn into a -6 to get rid of this 6z. So I can multiply equation 3 by a -3, add that to equation 1. Can you help us, please? Make sure I don't even know something here. So -3 times 3, equation 3 is -6x minus 9y minus 6z is -12. Equation 1 is 3x plus 5y plus 6z is -1. You add these, you get -3x, that's minus 4y equals -13. And I can call this equation 5. So that's the point. So that's the first step of solving systems of 3 equations. Get rid of one of the variables, and that's what I did. I got rid of the z's. From here, if I look at both these equations, I want to get rid of another variable, because that's the point of this whole thing. Get rid of one variable at a time. I got rid of the z's. Now I want to get rid of the x's or the y's. Doesn't matter which one. But in this case, the y's are already pretty much set up for me. If I add both equations, the y's cancel out. So equation 4 plus equation 5, 9x plus 4y, that's 7. Equation 5, -3x, minus 4y is -13. Add these, that's 6x is -6, or x is -1. And once you have one of your variables, all you need to do now is work backwards. You kind of back substitute. We're just kind of plugging it in backwards. So x is -1. We're going to plug that into equation 4 or 5. Doesn't matter which one. I'll use equation 5. So I have -3 times -1 minus 4y is -13. 3 minus 4y is -13. Or -4y is -16. Or y is 4. So I have my x value, I have my y value. All that's left is to figure out what's my z value going to be. And because I have x's and y's, I'm going to plug them into one of my first 3 equations, because that has x's, y's, and z's. I can solve for z pretty easy. I'll use equation 1, but it does not matter which one you use. So 3 times -1 plus 5 times 4 plus 6z is -1. -3 plus 20 plus 6z is -1. Or 17 plus 6z is -1. Or 6z is -18. Z is -3. I'm doing this a little quickly, but you're just solving for z. Do y'all have any questions about anything I've done throughout this whole thing? Are we good with that, guys? All right. So z is -3. The last thing that you have to do is you have to list this as x, y, z. So you have -1 for, I think it was -3. Yeah, -3. And that's your answer. Any questions about that? All right. Next one. Linear programming problem, number 50. For this one, we're told a bakery bakes 2 types of pastries, cakes and muffins. Each cake requires 2 hours of labor and 3 units of material. Each muffin requires 4 hours of labor and 2 units of material. The company has a maximum of 100 labor hours and 80 units of raw material available. Each cake nets the bakery $20 of profit. Each muffin nets the bakery $2 of profit. I don't want to solve this one. All I want is the objective function and the system of inequalities that represents the constraints. So linear programming, a quick overview of what that is that it's a way to figure out what the most optimal solution is going to be. And that's what the objective function is, because this is like a real world application that's actually used in the real world. Not just kind of, we just say it is, this is actually used. In this problem, we have a bakery. They obviously want to maximize their profit. And that's what your objective function is, right? It's called the objective function because that's your objective. You want to maximize your profit. So the objective function, that's going to be my profit, which is, I'm told it's $20 of profit for a cake and 2 per muffin, and X is the number of cakes. So what I get is that my profit is 20X plus 2Y. That's my objective function. And I like to write on the side max, just to remind myself that I need to maximize that. So my profit is 20X plus 2Y. And then my constraints, are basically just what do I have to work around. Usually that's like material or hours in the day or whatever it might be. It's stuff that you need to work around that you just can't avoid. That could cut into your profits. Right? In this case, the constraints are going to be labor and material. Labor material isn't infinite. You only have so much hours you can work in a day and so much material you can use. So when I'm told for labor, right, each constraint or each inequality is based off a certain constraint. So in this case, what's holding me back is my labor and my material. Each one gets a constraint. For labor, I only have 100 hours of labor to use. So that's why 100 needs to be less than or equal to 2x plus 4y. Right, I only have 100 hours, so the amount of hours I put into my cakes, which is 2x, and my muffins, which is 4y, has to be, 100 needs to be greater than, other way. 100 has to be greater or equal to 2x plus 4y. You cannot put more hours than you physically can do into your job. The other constraint is going to be based off the material that you have. I only have 80 raw material to use, so like eggs, flours, milk, whatever. I only have 80 units of that to use. And of those 80 units, the cake requires 3, so 3x, and the muffins require 2. That's my constraints. That's my objective function. Does that make sense? Any questions about that? All right, that's all I need to do. I'm not going to solve this one. All right, I'm going to graph the feasible region here for the following system of inequalities. So I'm told x is greater than or equal to 0, and so is y. So I only care about the first quadrant. Also, these two are pretty much always constraints in any linear programming problem. I kind of call them like invisible constraints because you can't, like in the previous problem, you cannot bake a negative amount of cake, right? You can't bake a cake and all of a sudden you also want a cake. It doesn't really work that way. So for these, you're always going to be, or linear program, you're always be in the first quadrant, and now you want to graph these problems. So the first step is to make them as y equals. So we have negative 2y is less than or equal to negative x plus 4. Divide by negative 2. Y is greater than or equal to 1/2 x minus 2. And then for the other one, I'll do that in blue. Same thing, 4y is less than or equal to negative 3x plus 12. Divide everything by 4, y is less than or equal to negative 3 over 4x plus 3. So all I did was fix these inequalities to make them y equals. All right. So that's what I have. And for these, you don't need to graph them one by one. All you need to do is figure out, well, what's my x and what's my y intercept. So for the green one, I have a y-intercept of -2. That does not help me at all. So let's figure out its x-intercept. So for this one, x-intercepts happen when y is 0. So we can say, well, 0 equals 1/2 x minus 2, or 2 equals 1/2 x, or x is 4. So I have a y-intercept, but it's in the negatives. I don't care for that negative. So instead, I'm going to figure out its x-intercept because you need that anyway. And that's at 4. I'll put it right there. It's a positive slope, so I know that I'm going up this way somewhere. Does that one make sense, guys? That one's kind of confusing because there's no y-intercept that we graph. All right. So for the blue one, same thing. I have an x-intercept of 3. I'll put that right here. And then my y-intercept, same thing. That happens when y is 0. Or sorry, x-intercept happens when y is 0. So 0 is negative 3 over 4x plus 3. Subtract the 3. Negative 3 is negative 3 over 4x. Multiply both sides by negative 4/3. And you get x is 4. Is everyone with me? Y'all know what I'm doing? So my x-intercept for the blue equation is 4. So from 3 to 4. Now you figure out, well, what's my answer going to be? For the blue one, my inequality is everything below it. So what I do is I just kind of draw lines going down. So I kind of know which area should I shade. And I'm going to see, well, where do all the arrows kind of intersect? For the blue one, I'm going down. For the green one, I am going up. So it looks like I don't actually intersect anywhere. There's no arrows going into the same portion. So that's why here there's no solution. You're just not intersecting anywhere. The shaded regions aren't, shaded in the same area, so there's no solution. They both touch 4. Actually, you're right about that. It should be 4. X is 4. Because they do both touch 4. Yeah, so I guess it's actually x equals 4, and that's it. So, yeah. Thanks for it, though. That's right. It is actually just 4, actually. You're right. You gotta fix it on the key. Yeah, because it's great. Yeah, because it's only 4 because it's both greater than or equal to. So that's why it works. Cool. All right. Any other questions here? We're good. All right. This is now on the linear inequality worksheet I gave you guys. It's a handout. We're going to go over this, how to graph these. I had a lot of questions about this stuff, about how to graph quadratics. We're going to go. So I'm just going to put a color for each one. The first one's green. The second one is blue. So for these, look at the first one. I have 1/2 x squared plus 6. It might not look like it, but that actually is in vertex form. It's just that your vertex is 0, 6. So I have 0, 6 right there. And what I would do when I'm graphing quadratics is I'm just going to make an XY table. And making XY tables will work for any function that you want, because you plug in x, you're going to get a y out of it. So here, I have 0, 6. I put that right in the middle. And I'll just go with 2 and 4, and -2, -4. I'm choosing 2 and 4, -2 and 4. I'm jumping by 2s because the a value is 1/2. If you jump by 2s, you don't get fractions. You could use 1 and 2 and get fractions. That's okay. I just would rather not do it. So you plug in 2 into the function, you get 8. You plug in 4, you get 14. I'm plugging them into this function right here. So if y is 1/2 x squared plus 6, and you plug in a 2, that's how I'm getting 8. All right, so you can graph that 2, 8, and negative 2, 8. The 4, 14, all the other ones are too big. I'm not going to graph that. For the blue one, same thing. I have a vertex of 0, -4. I'll make an XY table with the vertex right in the middle and see, well, what are my points going to be from there? I'll use 1 and 2 here, and -1 and -2, because I don't have any, what's it called? Any A value makes me want to jump by more than that. You plug in 1, you get -1. Plug in 2, you get 8. And these match. So you have 1, -1, 2, 8, -1, -1, -2, 8. So you get that. Right? Exactly. Yeah, if it's a fraction, you jump by the denominator just so you don't have to do a fraction, right? Because 2 squared, no matter what it is, it's going to be divisible by 2. That's why you jump by that. It doesn't matter. You jump, do whatever you want to do. All right. Good.
Why do you use -2 and -4? Why do you use those numbers?
Right here. I just choose because I start with the vertex right in the middle, and I just choose points to the right and points to the left. Because you want to know what's happening on both sides of the vertex. You can do whatever you want, but usually you want to pick whole numbers closest to it. So after 0 is 1 and 2, and you match that with -1, -2.
Why do you not do that?
But in the green one, I didn't do that because the 1/2 will make it, if I plug in a 1, you get a fraction. You get 1/2 plus 6. You could do that, it's okay. I just don't want to do a fraction. So I decided to jump by the denominator of the fraction so you don't get any fractions. All right, now to graph the actual inequality. The blue one I want to be greater than. So again, what I do is I just kind of draw lines on each segment. So I kind of know, well, where should I be graphing? For the green one, it's everything below it. So again, I'm going to draw lines in these segments that will be shading for that green. Then I'll look at it and I see, well, where do I have arrows from both graphs intersecting the same same place? And that's just the middle one. I'm going to do it in red. And that's what your answer is going to be. Make sense? You really can't. I guess you kind of can. Let's just leave it like this. Yeah, shading is the answer in this case. Yeah. Maybe. What? Could be yes, could be no.
They'll ask you like, what is a solution? And you just like look at any point that's indicating.
If this is on the test, and if we ask you for a solution, yeah, give anything in the shaded region.
Can we use 2 and 8?
In this case, yes, because they're both equal to. So 2a would be part of the solution. But what's actually I wouldn't do. Any other questions here, guys? No? All right. Number 7 on the test review now. This is one I got a lot of questions about. We're going to go over it. So on this one, write the precise equation of the parabola whose lattice rectum travels from b -5 to b7, and whose directrix passes through the point 8 minus b 19, and where b is greater than 3. All right. So for this one, I have a lattice rectum of b -5 and b7. So I'm going to go ahead and graph that. So remember, any type of these weird parabolas, really any problem where you can draw a picture, always draw a picture. It makes your life a lot easier. Be able to visualize everything, kind of see all the information as a picture. You're able to see everything at once. It makes your life easier. After that, I have a directrix. I really don't know which way it is. because if your B was 3, you have 8 minus 5 or 5. If it was like 7, or say it was like 10, you have a negative B. You don't really know what size it's going to be. I'm trying to say. It's hard to tell. So really with these pictures, draw something. If you're not sure, just draw something and see what you're going to get. So because my lattice rectum is this right here, I know that my quadratic will open this way, and that's how I knew my directrix is a line going up and down. All right. Really, I should have drawn the quadratic first and then drawn the directrix to know that it's going up and down, but that's how I figured out that it's going up and down. And that tells me that this directrix is x equals 8 minus b. Go ahead. To the right of it? To be honest with you, you really don't know. I just do something. Sometimes you just don't know what it's going to be, and maybe your picture ends up contradicting the actual answer, and that's who cares. The picture isn't the answer. So for now, I would say just draw something and let the math figure out the numbers after that. Right? That's what I say. That's what I would do. Right? Like a lot of times, like the warm up you did in class, a lot of times you draw that. Maybe the point you drew isn't accurate. The picture isn't accurate. Like maybe you drew the point above the focus. Like, you know what I'm talking about? Maybe you drew the point above the focus, but the point is actually below the focus. Who cares if it's accurate or not accurate? The picture just to kind of see what's happening, but then the math will give you the actual answer. Does that make sense what I'm saying? So from here, that's my x value. I know that my focus is right in the middle of these two endpoints of the lattice rectum. So I know that this will be b comma 1, right? Average out 7 and negative 5. That gives you 2 divided by 2 or 1. So my focus is B1, and that tells me that my vertex right here is some h comma 1, right? Everyone with me? That's my vertex h comma 1, and I need to figure out, well, what's my x value going to be? Well, I know that this point right here on the directrix is some 8 minus b comma 1, right? And I know that the vertex is always right in the middle between the directrix and the focus, right? Everyone with me? It's right in the middle. So if I just took the x values right here and average them out, you get your h, right? Because it's right in the middle. If you added the x's and divided them by 2, that gives your h value. So your h is 4. I'm averaging them out. I'm averaging out the x's, so I want to see, well, what's it called? What's the vertex going to be? Where's it going to be? Right, because it's going to be right in the middle between the two. So I kind of just averaged them out and said, okay, well, what's it called? It's going to be right in the middle. So I average out the x values right here. 8 minus b plus b divided by 2. That's the midpoint formula. So if you have an x of b and an x of 8 minus b, if you add them, divide by 2, you get 4. So average might get b value of 4. Right? So my 4p, that's from 7 to negative 5, that's 12. P is 3. Does that make sense? So P needs to be 3, and I'm told B needs to be bigger than 7, right? This is what I'm going to figure out, well, which way should I really open? So if my P is 3, and I have a vertex of 4, 1, what should my B be? What are my two possibilities for B? 7 and 1, right? Because from your vertex, you either have to go to the left 3 or to the right 3, right? So in this case, what's it really going to be? 7, because B needs to be greater than 3, right? So in this case, B needs to be 7. So what does that tell you about this picture that I drew? It's wrong. I drew a wrong picture. But it's not a big deal because I don't care for the picture too much. I just care, well, what's it going to look like? I can draw another picture and say, okay, I have a vertex now of 4, 1. My P value is 3, so my B needs to be 7. So right here, 7, 1. And now I'm opening this way. you can draw another picture. So if you're not sure where to start, just draw something, figure out something, and figure out, well, what should everything be? Does that make sense what I said? Are you okay with this, guys?
If it's like on a quiz, would we have to like redraw it?
The thing is, all this stuff right here is just work. Like, I'm not gonna sit here and say, oh, you draw it backwards at first and you take points off. No teacher's gonna do that. This is just work. So you don't, even if you got to this part right here, you realize, oh, B needs to be 3. I mean, B needs to be 7. So I'm actually opening to the right. So my 4P is positive. I don't care if you drew another picture or not. It's because that's just work. It's like doing extra work. It's not a big deal. You know what I'm saying? It's really about, it's just all your work in there for the picture. You don't even need to draw a picture if you don't need to. But it's better to, right? So what I know so far, 4P is 12. It's going to be a positive 12. And I also know that my vertex is 4, 1. And I'm opening to the right. So you have y minus 1 squared equals 12x minus 4. And that's going to be your answer. Right? For which one? Oh, because I'm told the problem B is greater than 3.
Okay. You
That's
didn't need to find B though, did you?
You didn't need to find B, but because I wasn't sure which way it opened, you need to check, right? So it's like, oh, you have a vertex of 4, 1. So I can either subtract it and go to the left to my focus and get a 1, 1, or to the right and get 7, 1. I'm not sure because I can open left or right. So from there, you can see, okay, well, my B needs to be greater than 3. So that tells me I need to go to the right to 7, 1, not 1, 1. So it's telling you which way to open. So it tells you it's a positive 12, not a negative 12. There's a lot going on here, but a lot of this is really just draw a picture, try to understand what it's asking, what's happening. Any questions about that? All right, this one, write the equation of a parabola with a focus 2, negative 5 over 2, and a directrix of y equals 5 over 2. All right, so if y equals 5 over 2, let's draw that. That's just 2.5, right? 2.5. A focus of 2, negative 5 over 2. So down here, 2, 2.5, negative 2.5. And now you figure out the equation of the problem. So from here, same thing. I'm just going to figure out, well, what's the midpoint between these two? So the midpoint of these two, I know that my vertex will be right here. So I know the x value is 2. But I need to figure out, well, what's the y value? So what's the y value going to be here? It's going to be 0 because it's the midpoint between negative 2.5 and positive 2.5. So the vertex is 0. That's pretty easy. And what's my p value? It's 2.5. So 4p is going to give me what? 10. 10. It's going to be 10. So my answer is y, really just y squared, y minus 0 or y squared equals, it's going to be a negative 10. So I'm opening down. Oh, sorry, not y squared. X, yeah, sorry about that. X minus 2 squared equals negative 10 y. Yeah, it's opening down, so you know that x is going to be squared, and also 4p is negative. So x minus 2 squared is negative 10y. So this problem, it looks a lot harder than it actually is, but if you draw a picture, it makes everything pretty straightforward. Are we good here? All right, this one. What value for Q will cause there to be only one solution to a system? So in this problem, the only time you'll ever have one solution to a system is if you have something like y minus 3 squared equals 0. In something like this is where you have only one solution of 3. So if you have one solution to a system, what you're looking for is a perfect square trinomial, like y minus 3 squared. So for this problem, what I'm going to do is I'm going to solve this for x. So x is 3y plus q, and plug it into the first equation. To get y squared minus 5y plus 7 is 3y plus q. Are you okay with this? All right. And then I'm going to add like terms to subtract the 3y. Y squared minus 8y plus 7 minus q is 0. That's what I'm doing. And remember, I want this to be a perfect square trinomial because, like I said before, for this to have one solution, you need it to be like y minus 3 squared equals 0 or something like that. So I know that this 7 minus q, whatever that is, it needs to become a number where it's a perfect square trinomial. Are y'all following what I'm saying? Are we good? I just made that up. I just made up numbers. So that the green box, I just made something up just to kind of show you the example of what it needs to be. I need this problem to kind of become a perfect square trinomial like that. So look at this problem. I have 7 minus q, right? Well, if you guys remember from the completing the square, what we did to figure out this number to make it a perfect square trinomial is you took the b value, divided it by 2 and squared it, right? So that means I need negative 8 divided by 2 squared, which is 16, to equal 7 minus q. So I need to be a perfect square trinomial, right? So that means this last term needs to be b divided by 2 squared. So if I solve this out, 16 equals 7 minus q. Well, q is going to end up being negative 9. And that's how you do that problem. Does that make sense? It's kind of a confusing problem because of this part right here, and also understanding that it needs to be a perfect square trinomial so that it will have one solution. But are we okay with that, guys? Any questions about it? Good. All right. So I said I'm going to do a linear programming problem. Let me go grab one. Put it on here. All right. So here's a linear programming problem. This is not from that worksheet I gave you guys before. Those 3 problems I gave you before is a lot harder than what you'll see on the test. If you're able to do at least one of those problems, honestly, you're doing great. You're in good shape for the test. All right. But here's a linear programming problem. So y'all haven't seen this problem yet. So honestly, for y'all watching the video, if you want to pause it and do the problem first, and then we can go over it, that's what I would do, because you probably haven't seen this one yet. But if you haven't, we're going to go ahead and just go over it right now. I'm told the area of a parking lot is 600 square meters. A car requires 6 square meters of space, and a bus requires 30 square meters of space. The attendant is new and can only handle 40 vehicles. If a car is charged $3 and a bus is charged $8, I want to find how many of each type of vehicle should be accepted to maximize income, and what is that maximum income. So anytime you have a linear programming problem, you kind of want to figure out, well, what's my objective going to be? What am I trying to do? So the objective function here, well, it's still a business. I'm making money. My goal is to maximize profit. So my profit is going to be 3C. Well, before that, I'll get in with C's and S's. I'm going to say X is cars, Y is bus. I don't want to use C and S or C and B. I'm using X and Y. So 3X plus 8Y, that's be my profit. My profit is 3X plus 8Y, and I want to maximize this. And then from there, I need to figure out, well, what are my constraints? My constraints are what's kind of holding me back from doing even more, making even more money. So in this case, if I look at it, my constraints is I only have 600 square meters, and this attendant can only handle 40 vehicles. So you need to figure out what's holding back the business. In this case, it's space and how many cars the attendant can handle. So for the space, each car requires 6 square meters of space. So 6X plus 30Y, and that needs to be less than or equal to 600. Right? I can be using less than all 600 square meters of space, but I cannot use more. So that is my my constraint. And at the same time, my other constraint is going to be that the total amount of vehicles needs to be less than or equal to 40. I cannot go over. Everyone okay with that? All right. So let's go ahead and solve these for y equals. So for the first one, solve it for y equals. So you have 30y is less than or equal to negative x plus 600. Divide it out by 30. Y is less than or equal to negative 1/5 x plus 20. And then for the blue one, x plus y is less than or equal to 40. Same thing, solve that for y equals. Y is less than or equal to negative x plus 40. Is everyone fine up to here? All right. From here, we're just going to graph it. And remember, we always have like two kind of invisible constraints, right? You should always know that x has to be greater than or equal to 0, and same with y, right? You can't have a negative amount of cars parked in your lot or a negative amount of buses parked in your lot. It doesn't make any sense. So these are kind of invisible constraints. All this is really saying is that you're doing the first quadrant. That's why we give you graphs like this and not a full-on grid. Okay? And then from here, like I said before, we're just going to figure out the x and y intercepts and go from there. So I'll do the blue one first because the one's a little easier. For the blue one, my y-intercept is 40. And let's do both. Y-intercept is 40, and so is the x-intercept. And then for the green one, well, the y-intercept is 20, so I can put that just right here. Why not? And now for the x-intercept, that happens when y is 0. So you have 0 is negative 1/5 x plus 20, or negative 20 is negative 1/5 x, or x is 100. So we'll do that. Everyone with me so far? So both of these have to be less than or equal to. So like I said before, I'm just going to draw arrows in each part of it. So I need to be below this green line. So I'll be shading in these 2 points. For the blue one, is also less than. Draw arrows in each part. And the part that has both arrows in it is where your answer is going to be. And that's going to be this part right here. So we're almost done. I got my feasible region, right? This red part, that's my feasible region. It's all my possible combinations of buses and cars that I can use. And now you figure out, well, what's the optimal amount? So if I look at each point, each corner point, that'll be each point that makes this shape in this red, I don't know what it is, what shape that is, but all the shapes here. So technically what I have is 0, 0, 40, 0, 20, 0, or sorry, 0, 20. And whatever this point right there is going to be. Everyone with me? I need to figure out this point right here, the intersection of the 2 lines. And also, well, let's go figure that out. All right, so I'm going to erase this word for the x-intercept. And now we're going to figure out, well, what should it be? I have 2 lines. You can do elimination, substitution, or just set them equal to each other. It doesn't matter. It's a system of inequalities. Solve it however you want to solve it. I'm going to set them equal to each other. So negative x plus 40 is negative 1/5 x plus 20. Did y'all get why I did that? I don't want to keep going if that's if I kind of skipped a few steps. Are you okay with how I got that? I want to figure out the intersection of the blue and the green line. So you set both those lines equal to each other. You're going to figure out what that intersection is going to be. So from here, I'm going to subtract the 20 over and add the x over, and you get 20 equals, that ends up becoming 4/5 x. Multiply everything by 5/4. And you end up getting 25 equals x. So my x value here is 25, and I just need to figure out, well, what's y going to be? Plug it into whatever equation you want. The blue one was pretty easy. So you get y is 15. And that's my last corner point. That could be a possible solution. Everyone with me? So my last corner point is 25, 15. So these are my 4 possible corner points, but honestly, you can cross out 0, 0 right away, because how are you going to maximize profit with 0 cars and 0 buses, right? So these 4, plug them in, see what you get. So for the first one, 40, 0, well, my objective function, you can rewrite it, 3x plus 8y. So you have the profit is 3 times 40 plus 8 times 0, or 120. For 0, 20, you have 3 times 0 plus 8 times 20, which is 160. The last one, P is 3 times 25 plus 8 times 15, which is what, 75 plus, that's 120, right? So 195. So my answer is 2515. You cannot just give an answer like that. You have to write it out. You have to say that's was it 25 cars? Yeah, 25 cars and 15 buses. And that's your answer. And that gives a, oh, as for the maximum income, the maximum income is going to be $195. Yeah, because it asks what is the maximum income and also how many cars and buses do you have to have. Depends what the problem's asking. In this case, ask for both. Make sense? Any questions about that? Are we good? Great. All right. And we stop the video, and that's it.